Okay, so I'm going to talk about the concept of spin polarized, the density functional theory, and then the density of states for the spin polarized density functional theory. Sorry, words are hard today. Okay, so first, the density functional theory is just a computational modeling method in order to investigate electronic structures of multi-body systems and their properties. So the first theorem that we discussed yesterday talks about the ground state properties and how they're uniquely determined by those three spatial coordinates of an electron density. And then the second theorem defines an energy functional for the system and proves that the correct ground state electron density minimizes this energy functional. And so for the spin polarized versus spin restricted, the spin restricted is when you do not specify any keyword in the in-car to modify the spin components, and the electrons that are computed are the same regardless of the spin. And then for the spin polarized jobs, we treat them with spin up electrons separately from the spin down electrons, and those are mostly used for transitional metals. And so how we do this, we modify the in-car, and then do the NSW equals 0 and I spin 2, and then we can run the job for it. And from there, then we input that tail line that Wendy taught us, and then states up and states down, and then we can get all of those values that we need, and then that's the portion where you type in the range and the alpha, beta, and all those things in order to get the differences between the density of states up and down. And then when you plot them as a PDF, it looks something like this. And so that proportion is the spin up component and then the spin down. And you'll notice that the up and down do not match up vertically, and that's due to the differences in electron population between the up and down components. And so you can see the differences in the bottom here as well. So this is what I'm working on. The top portion is rhodamin B, and then this is a silica slab. So I have 3 different types of dyes that I'm working with, so I'm going to work to try and put these different types of dyes, methylene blue, rhodamin B, and eosin Y, on top of the silica slabs, and then optimize them from there. Any questions?
Okay, I think Caitlin.